Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all. First and foremost, I would like to thank Jim for coordinating this session, especially Dr. Nizamuddin. Accidentally, his name is similar to mine. So if you have questions, then you can ask either of us throughout this session. Basically, when PGIM approached lecturers in UTM, if we have anything to share with the industry, this particular topic pop up in my mind actually, data analytics. The reason being is um, due to from my limited dealing with industry in Malaysia, especially among the SME. I think the adoptions of data analytics in decision making in industry is quite lacking. So I would like to take this opportunity to actually just introduce a bit on data analytics and what it can do, so that hopefully whoever attended this particular sharing session today, will be the catalyst to the change in your organizations with regards to data analytics. So having said that, let me proceed with my sharing. By the way, this is a 1 hour session, so it's very short session. If you have any questions with regards to the presentation, you can stop me in the middle of the presentation, and we'll try to answer as to my capability. Okay, so my end in mind for this particular session is this. One is I would like to introduce a concept of data analytics to all. So my target audience in here is to the SME that I found a bit lacking in terms of data analytics implementations. But I'm quite sure there are many industry players from big organizations, and I'm quite sure for the big company, SME and big corporation, they have first, second, third tier suppliers, and most probably those suppliers, some of those suppliers are SME. So hopefully this will actually open up your mind to actually try to impart your knowledge in data analytics, and also develop your supplier so that they can actually improve their operations using data analytics also. Right? So for those that's familiar with the topics, this will be like a review. It's like a peanuts. For those that that are very new in data analytics, don't be afraid, and that's part of the end in mind of my presentation. So again, back to my end in mind for this particular session, sharing session. I would like to introduce the concept of data analytics to all of you, what it's all about, where it's coming from, what it can do, so on and so forth, in a very layman term, And secondly, proceeding from that, I would like to put you at ease with data analytics. So don't be afraid. Data analytics is not for somebody that has, in-depth knowledge in statistics or programming. I think any regular engineers or production supervisors can do it. There shouldn't be any issue for you to perform some level of data analytics. And my last end in mind for this particular sharing session is to give you a glimpse of data analytics potential by sharing some case studies. So basically, this is 1 hour presentation as mentioned just now. This is very surface information for you to actually understand the concept of data analytics, make you not afraid to data analytics, and to have some appreciations in what data analytics can do to your operation. Right. Okay, let's move this thing first. Right. So my presentation outline will be categorized into two groups. Very simple. One is data analytics background. This is where I'm going to introduce what's data analytics, so on and so forth. And the second items that I would like to share is basically data analytics made easy. How going through an example, a case study, and we're going to look at how a very simple data can be processed using a very simple techniques and very available, readily available software in your organizations. And what informations you can get out of that data analysis. Right? So my presentation outline is basically focusing on these two items. Okay, so what is data analytics? So data analytics is basically just move. So data analytics is basically a science of analyzing raw data to make conclusions about that information. So data is information. So this is data. So data is information, right? So what data analytics do is a science. So is mathematics is something that is get firmly grounded on the ground on how to analyze the data so that you can make conclusions out of it. Hmm? So that's basically, in simple term, what data analytics is. For example, you have this raw data. So this is basically maybe a raw data about people salary in an organization. You have a social security number, name. So in the States, a social security number is like your IC number. Every single person has their own social security number. So you have name, gender, titles, meaning that this is a job positions, salary, and category. So I'm not sure what category is for. But basically, if you have this set of data, then what conclusions can you make out of it by looking at it? Nothing much, right? So you need to process it so that you can come up with a conclusion out of the informations that you have. Right? So it's a broad term that encompasses many diverse type of data analysis. So one part of a data analysis is data analysis, and there are many kind of data analysis that you can do depending on what you want to achieve. We're going to go in a bit detail on that later on. Okay? And any type of information can be subjected to data analytics training. So any data can be used. Any data can be analyzed by means of data analytics. So it doesn't matter if it's engineering, you're in engineering, or in operations, in productions, in a service sector like hospitalization, hospital sector, or hospitality sector like hotels, so on and so forth. The data that you collected actually can be analyzed. The important thing is you have the data, right? So let's move. So that's basically what data analytics is all about. A bit on the difference between data analytics and data analysis, because I'm going to change it interchangeably. Basically, in simple terms, data analysis is a subset of data analytics. Right? So we talk about data analytics. You're talking about the complete data management of data, from the analysis, from data collections, from organization, storage, and tool and techniques to be used to analyze that particular data. But for these particular sessions, I'm not going to go through those other things. I'm not going to go through data collections, so on and so forth, because it depends on the nature of your operations. So if you're in manufacturing, then the methods of data collections may be through sensors, so on and so forth. Right? If you are in a service sector, then basically some examples of data collection that you can make is, for example, in hospital, once a patient registered, right? So you have a time. Once the patient is handed over the bill, that's the completions of the patient being treated in that particular hospital. So you can look at duration of time for the patients to get the service in that hospital. So you can collect that data in that manner. So data collections is the methods of data collections depends on your specific industry and nature of your operations. right? So mainly in this particular sharing, I'm going to talk about data analysis. Data analysis. And data analysis refer to process of examining, transforming, arranging a given set of specific ways, data in given specific ways in order to study its individual parts and extract useful information. So basically, data analysis is this. You're talking about examining, transforming, arranging data in specific ways so that you can get informations and make conclusions out of that data, right? So that's data analysis. How do you do that? There are many methods in doing so. So I'm going to share some of the methods that you can use that can be easily implemented in any operation. So why data analytics is important? So as I mentioned just now, right? So you can have information with regards to, let's say, this data, right? And this is only like 16 line items. You might have data like 2,000 line items or 20,000 line items, right? So if you look at that data, you won't be able to come up with conclusions about the information that you have unless you do some data analytics. So data analytics will reveal trends and matrices that would otherwise be lost in the mass of information, so that you can make a better business decisions, right? So, for example, in here we have informations about names, gender, title, which is job functions, salary. Right? So you can easily do data analytics, a simple data analytics, to understand what is the mean or the average salary of manager, sales rep, so on and so forth, for all various job functions. Right? You can also slice the data such that you would understand, let's say, if it's a male manager, how much would you get? If it's a female manager, how much you get? Is there any difference in salary scale between the male and female manager? Right? So if you perform data analytics on this particular data, you can slice it in so many ways, and you can get so many informations, and you can use that informations to help your business to optimize your performance. Right? So it will help business optimize their performances by sorting and storing and sorting large amount of data. And you can, if you can do it in a very short period of time. If you have everything set up, if you have what do you call it, the algorithm or the procedure or the tools set up, designed properly, then you can do the analysis with basically a click of a button, a button, right? So why data analytics is important? Not because you want to have a fancy graph, so on and so forth, but you want to understand the trends of the informations that you have, so that you can make good business decisions, be it operational or strategic business decision. Okay. Any questions so far? Let me just move. So there's a survey, interesting survey done by bioworldwide.com in this website, and it's actually a survey on the 3 reasons why people do not take full advantage of analytics, and what to do about it. Right? So the three reasons why people or organizations do not take full advantage of data analytics is, the first one is old habits die hard. So this is the survey, not me saying it. So it says that from the survey, most managers still aren't interested in anything other than red, yellow, green status report. Meaning that in a meeting, most manager would like to know whether you are in trouble, you're so-so, or you're doing great. Right? Without without interest in going in depth in terms of the data, so on and so forth, that support it. So if that happened, then basically you're going to have uh, very low management commitment in data analytics implementation. And what to do about it? Suggestions from the research says that you need a mind shift that moves from having interest of here we are to here's what we can do about it, right? So again, I'm using these sessions actually to recruit catalysts of change through industries, especially in the SME, so that that you guys can actually convince the management, or if you are a management, convince yourself that data analytics is important, and it need to be supported, and there need to be a mind shift with regards to have wanting to know here we are and here is what we can do about it, right? And you can do this, you can understand here is what we can do about it with data analytics. The data that you have can be analyzed properly, and it can tells you what need to be done in the future to improve your performance, organization performance. So second reason why people don't adopt to this particular data analytics initiative is you don't know what you don't know. So from the survey, it seems like people here heard about data analytics, but they don't actually know what it is in depth, or even in on the surface. So it's just like industry revolution 4.0. We heard the terms all the time, but what does it mean in detail, and what benefits it will brought about, and whether your organization should embrace it or not, right? Is something different. So you might heard about it, but do you really understand it? Do you really want to get your organizations involved in that particular initiative or not? Right? So that's the second reason. You don't know what you don't know. So it is difficult to fully embrace analytics if you're not sure how they can benefit your organizations. So if you don't know how it can benefit your organizations, then basically you need to understand. And once you understand, you need to communicate the value of data analytics to your peers or within your organizations. I think the best thing is actually to do it and share the result with your peers, with your management, such that they can actually value the importance of data analytics. And the third reason why data analytics is not being readily adopted by some company is data analytics aren't one size fits all. So data analytics is something that need to be customized. Right? So if you want to implement data analytics for your organizations in manufacturing, uh, and your manufacturing has different sections, you cannot just do the same analysis to all sections in the organizations, to all departments in the organizations. You cannot do that. You need to be customized. You need to be customized because your goal for each of the department would be different. Would be different. So need to be customized for each operation, and because of that, it seems it often seen as overly complicated and time consuming. So when somebody try to introduce data analytics to be implemented, and one of the perception is basically the activation energy is just too high, meaning that it is going to be hard to implement it because you need to invest in people, you want to invest in a software, and so on and so forth. So because of that, managers shy away from it. So basically, this is one of the main reasons for this particular sharing session is basically to do this. Need to understand and communicate the value of this data analytics to the players, to the industry players. So that's my main intentions actually in this particular session. All right. Types of data analytics. So there are many types of data analytics. It can be categorized into four. One is called descriptive analytics. You can do diagnostic analytics, predictive analytics, and prescriptive analytics. Right. So as the term indicates, the analysis involved is become deeper and deeper as you move from descriptive analytics to prescriptive analytics. Right. Just pull this. Okay. So what's descriptive analytics? So descriptive analytics is, will tell you information what has happened over a given period of time. Basically, that's a descriptive analytics. For example, so this is, I think this is examples of a company that's doing, let's say, online business, right? So then you can get based using descriptive analytics, you can actually look at a number of views trend for the past, let's say, 1 week. Has the hit to your web page going up or going down? And are the sales stronger this month or last month? So you can do data analytics in terms of the hit in your web page if you're online, you're doing online business, and does that translated into a strong sales this month than last month? So you can look at the trend where the number of hits going up, and does that translated into sale, right? So that's descriptive analysis. Another example is our COVID-19 case, right? So the information that you get day to day from the Department of Health in terms of number of COVID cases. So that's considered descriptive analysis. So you can see today is how many cases, next day is how many cases, so on and so forth. So that's basically descriptive analytics. I just remember one a chat that I have with my niece. My niece is a doctor in Labuan, and if you remember, about a few months ago, Labuan was really in bad shape in terms of number of COVID cases, right? And at that time, my niece was very busy. He said that he has to stay in the hospital for more than 12 hours, and the management of the hospital keep on pulling the staff that attending the patient to do a vaccination, right? So the focus of the management over there during that particular period of time, where the cases very high, is actually pulling people from the treating the people from the treatment of the COVID-19 to the vaccination, right? So she was complaining to me, and I told her, so the management is making decision based on data. So based on data analytics, if you look at the effectiveness of the vaccine around the world, how do they get the data? They do data analytics, right? It shows that those people that taking the vaccine will be not likely be infected, right, by COVID-19. And even if they are infected, it's not going to be serious for them to be admitted in the hospital. So they are making a strategic decision to actually focus on the on the vaccinations rather than putting people to sick people, readily sick people, right? So that's examples of how management can do data analytics to make a strategic decisions that might seem to be not a right and smart decision at a particular time, but in long term is a very good decisions actually. So that's examples of descriptive analytics. You can also perform diagnostic analytics. In diagnostic analysis is actually explain why something happened. Right? So this involves more diverse data input and a bit of hypothesis. Uh, for example, did the latest marketing campaign using prime TV advertisement, prime time TV advertisement impact sales? Right? So you can look at your data if you're in online, say for example, business. You can make, for example, Shopee, right? So they can look at the sales trend for the past, let's say, 1 month, and they can actually identify when they start the prime time TV advertisement campaign, and they can look at the impact of that particular advertisement techniques, whether it's actually increased the sales significantly or not. If it does, then basically maybe that's the advertisement campaign techniques they want to pursue in the future. If not, then drop it and move to something else. So that's the example of diagnostic analytics that can be done. Right? The other methods, data analytics method, is called predictive analytics. Basically, using predictive analytics, you can tell what is likely going to happen in the near term. So it's an improvement compared to diagnostic analytics. Predictive analytics actually can actually forecast what would happen in the near term. So, for example, what happened to the sale of a table fan or air conditioning system the last time we had a hot summer? So you can have data collections with regards to your sale, and then you also want to know what's the impact of hot weather. So this is probably in the four season countries. So what's the impact of a hot summer for the sale of a fan and air conditioning system? So you can actually get data from the weather department, and then you can actually do data analytics comparing the pattern of the hot summer season with the sales of table fan and air conditioning system. And from there, you can maybe come up with a correlation analysis to predict what would happen in the future if you have a hot summer season. So that's examples of predictive analytics. In COVID-19, you have seen this being used, and for example, what do you call it? When R naught is equals to a certain number, they can predict based on the statistics and the previous history. What would it be 2 months from now if we didn't do anything about it, right? Okay, so the last types of data analytics is called prescriptive analytics. In prescriptive analytics, then basically it will come up with suggestions of course of actions. For example, if the likelihood for a hot summer is measured as an average of 5 weather models is above 60%. So you can do in predictive and also prescriptive analytics. Most likely what you have to do modeling. So when you do modeling, then you can do various modeling techniques. You can use machine learning algorithm, you can use neutral network algorithms, so on and so forth. Right? So if this example says that if the average of these 5 weather models is above 60%, that you're going to have hot summer next coming summer, then basically you should hire temporary workers to increase output. to produce fan and air conditioning system. Right. So these are the various methods of data analytics that you can do. And as you move from descriptive to prescriptive analytics, then the analysis is getting more involved, but the information that you gain is much more meaningful to you. All right. So let's shift gear a bit. So basically, what I've covered so far is very general information about data analytics. What is it about? What it can do? Why people don't like it? What's the pitfalls? And basically, what type of data analytics that you can do. So let's me shift my gear a bit to focus on manufacturing analytics. So in manufacturing analytics, in general, it depends on the grouping of your functional in the organizations. Mainly, you have a supply chain. You can use data analytics for supply chain. You can use data analytics for product quality. You can use data analytics for field service and support. And you can use data analytics to create an efficient factory. So this is usually supply chain analytics is done by planner and buyer, right? Planner and buyer in organizations, we look at supply chains and use data analytics for that. And it involves, demand forecasting or the management, so on and so forth. For engineering group, usually focus on mainly, focus on product quality, and basically the data analytics to be done in product quality would be different compared to data analytics for supply chain. For example, so one of the items for product quality, data analysis for product quality, is real-time quality monitoring system, right? So how do you use data analytics to do this? So basically, for those that familiar with product quality in terms of real-time quality monitoring system, first thing you need to do is you need to define a process capability, right? And set from the process capability study, then you set the upper and lower control limit of that particular process. Then basically there is a sensor to capture the data, or people input the data to the system. And if that data is above or below that particular upper and lower control limit, then you are saying that the system, your process is not in control, and you have to identify the root cause of the problem and fix the issue. But in supply chain, it's different thing. You might not be interested in collecting such data. So that's the reason why I mentioned just now that the data analytics need to be customized depending on what you want to get out of it, right? So this usually supply chain usually done by planner, product planner, material planner, and material buyer. And product quality usually is focused by engineering group. Field service is basically a service group. And creating efficient factory, usually this is manufacturing, this is production. This is maybe supervisors or shift managers that's interested in this. So again, the data analytics for every single functional groups in here would be different. So that's why you have to customize it. Okay? And there are many data analytics software out there that you can purchase, but you still need to customize for your operations. So Microsoft have a Power BI, you have Tableau, QLink, so on and so forth. Right? And you have to spend some resources in purchasing, also training people in this to use this software. However, you can also perform data analytics to a certain extent using the software that's available in your PC right now, which is Excel. Right? You can use Excel for data analytics. right? You can use that self-assessment. And that's what I would like to share with you so that you can have a feel of doing some kind of data analytics using simple techniques and using the resources that you have in-house. So I'm going to share you a case study of manufacturing operation, and I'm going to show to you performing to perform the descriptive and diagnostic analytics only. But by all means, Excel can do beyond this. It can do predictive data analytics. It has that capability to do it if you know how to use it. And it can also use a prescriptive data analytics. So Excel is very powerful software actually, but it's not being customized. It's general software, so it's not customized for a particular specific applications. So you have to learn how to use it. But I'm going to show you a very simple technique on how to do data analytics using Excel on regular data that you might have in your possession, right? But again, I would like to stress that in data analytics, the data that you collect must be very sound. Data that you collect is a sound data, is a good data. It's not manipulated data. It's not errors data, erroneous data, so on and so forth. Because I'm quite sure you guys heard about garbage in and garbage out. So if the data that you start with is not good, no matter how you analyze it, the output will be also bad, right? And we are not going to talk about data screening, so on and so forth for now. But I just want to show to you how to do this data analytics. Very, very simple way, and you can get a very meaningful information out of it. Right? So all the analysis here, I'm using Excel, and specifically I'm using statistical functions and pivot table. That's all, and you have it in your Excel. And all the analysis is done in 10 minutes, less than 10 minutes. It's very simple analysis. And I want to show you what you can get out of it, of this kind of analysis. So this is the examples of the case that I'd like to share with you. So this is a yield of manufacturing lots of the same product under different conditions. So if you look at this, now you have a lot, you have a quantity. So you have I have here 20 lots of manufacturing parts going through the line, making the same product, but under different conditions because you have multiple operating organizations, right? And you have multiple machines in your production line, and the materials being used for that particular to produce that particular product is coming from different batch number. Let's say you collected all this data. Let's say you have they call it travel lot documentations that come with the lot. And you have the information about who's the operator, which machine it runs, what material batch number you have. And you have yield number for that particular lot. Yield is basically if you input is 100, yeah. So your output, if 90%, if 90 parts are good, then your yield is 90%, right? So if your input to the process is 100 parts and the output is only 98, then we have 98% yield, right? So what can data analytics do with this kind of information? Remember, I cannot show it here live using Excel because then might not have enough time because you have to pull out different softwares and so forth. Right? So the first thing, if I'm the engineer in this particular area, or if I'm the engineering manager for this particular area, first thing that I want to know is I want to know my process capability. Okay? So I can perform data analytics to find out my process capability for my yield by developing a yield control chart. So this is all done in Excel. So in this control chart, I have average. I have the low is lower control limit, upper control limit. The calculation is very simple. I'm not going to go through it very in here. But in the future, if anybody likes to know about it, then we can schedule a session, so on and so forth. So based on these informations that we crunch, we know that the process has capability to achieve average of 95% yield. So I know that my process has capability in average to produce 95% yield. So I can do planning now. I can do planning. So if I know if the raw materials that I input to the system is 100, in average I'm going to get 95 out of it. So that I can plan accordingly with what customer needs. Right? And another information that I can get from here, there is 99.7% probability that the yield for the process will be within 83.65 to 100%. So this is a control limit. When you calculate the control limit, the upper control limit will be 100 and something, 106, right? But because the maximum yield number is 100, then it should be from 83.65 to 100. Okay? So I know that my yield average is 95%, but you can fluctuate. And when it fluctuates, 99.7% probability that the yield will fall between 83.65 to 100% range. Okay? So that's the information that I can get from here. So this is kind of like descriptive analytics. And I know in the future yield, if the future yield deviate from this range, then it indicates there's abnormality in the process, right? So if I use this control chart, I use this upper and lower control limit. I keep on collecting data real time, right? If any of this data falls out from the control limit, I know that somebody need to take action because something changed in the production line. Something changed in the production line that actually impact the yield. So these are the informations that I can get from it, from this particular data. If let's say, for example, if I look at this yield, I say that I don't like 95% yield, and I think I want to find out how to increase my yield to a greater level, right? So what is the improvement plan that I can focus on to increase my yield? And I also don't like this range, 99.7% probability that my yield of 95% will range from 83 to 83.6% to 100%. I want to tighten this range. How can I tighten the range? Right? So with further data analytics on this data, I can do diagnostic analytics. If I do diagnostic analysis based on the information that I have, and if I use a simple pivot table, by one click, basically one click, one selection, and one click, I can get this data from Excel. Right? So this data will tell you the variability of the yield, average yield, between machine X, Y, and Z, and it can tell you how's the yield based on operator to operator variation. And also it can tell you what's the yield based on material batch from 1 to 3 to 1 to 7 material batch number variation. Right? So this is, as mentioned just now, this is a diagnostic analytics, where it tells you how to proceed with the continuous improvement recommendation. So if you look at this, I can come up with the conclusions there. The average yield can be increased further to 95% range. So if I were the department head or the manager of that particular area, I'm going to tell my engineers, hey, you guys can actually increase the yield up to 97% because I can see the 97% number in here, right? And if you look at the yield range attributed to the observed parameters, if you look at the range of yield differences, so machine to machine variations is 6.5%. From X between X versus Z machines, the yield is about 6.5%. So operator to operator variation is about 3.4%. And material batch number, batch to batch, material batch variation is 2.3%. So if I were to make decisions in terms of where the focus should be, then the focus should be will be at the greatest yield range, which is attributed to machine variation, right? So if I want to look at the improvement work in continuously improving the yield, I would like my engineers to focus on understanding why machine X is different compared to machine Y and Z. Right? So if they can understand what's the difference, then they can bring up the yield up to 95, 97% level. Right? Similarly, I can with a click and one drag, I can change this. I can get this information. I can get the standard deviation comparison between various machine, operator, and material batch number. Okay? So if I were to have this information, then I can actually tell my staff where to focus on in getting the standard deviation or the variability of the yield going down. Right? So to reduce the variability, focus should be given on both the operator and the materials. So if you look at the machine variability, the standard deviations is around 1. But when you look at the standard deviation for yield, and also material batch to batch comparison, you're talking ranging around 3 point something percent, which is 3 point something, 3.6, so on and so forth. It's not in percentage, it's in number, right? So basically, then the standard deviation for yield attributed to operator ranging from 3.1 to 3.6, indicating there's a systemic issue among the operator. So basically, I'm going to ask maybe the supervisors to look into SOP work practice among the operators so that they can be more consistent, so that can reduce the variability, the standard deviation down to respective number rather than 3 point something number. Similarly, I'm going to ask my material engineer to focus to work with the customer, to work with the supplier, not the customer, to the supplier, to understand why there is variability in the material batch. So you get up to 4.9%, 4.9 standard deviation for batch 126, which is quite high. And the supplier actually has capability to maintain low standard deviations, low variability in the material they supply to us, right? So with a simple data analytics on the data that we have using Excel under 10 minutes, then basically you can get this data. I'm going to ask my engineer to focus on the yield improvement, right? Understand the machine to machine variation. I'm going to ask my operation, my supervisors, right? Operation supervisors to understand why there's a lot of variations in terms of operator output, operator yield, and a material engineer to focus on working with the supplier to reduce the variability of incoming materials. So basically, it's a very mundane data that you have, right? Very simple techniques of data analytics using a very simple software, and you can come up with this data analytics report. So that I think point you to make decision in terms of what focus you should focus on to improve your operational performance. So in conclusions, we have 7 minutes to go. So in conclusion is basically decision, be it strategic or operational, need to be done based on data. I think is very important for decision to be made based on data, not based on sentiment, not based on gut feels. And in order for you to do that, data analytics is a very powerful tools to explain your data so that you can make decisions, a correct decision for your organizations. And if you have data and without being analyzed properly, and that's actually a waste of resources, because collecting data will cost you. You need to spend some resources, be it people taking it, jot down the informations, key in the informations, or investing in sensor to collect data, store it, so on and so forth. All those things cost money. So if you have data with it being analyzed properly, it's actually a waste of resources. And my last conclusions is start doing it with the data that you have and the basic software that you have. So my advice is my advice is actually start doing it. So if you have data, and start do some data analytics, simple data analytics using whatever data that you have, and basic software that you have. And from there, then maybe you can share it with your peers and management, and get them to be convinced that data analytics is a very powerful tool that's very important for you to make decisions, be it strategic or operational. So I think that's all I have in terms of my sharing for today. So I'm open for question and answer if there is any.
Okay, Prof. Maybe I have one question.
Yeah.
Compared to the data analytic tool that you show, is it comparable if we use SPSS analysis?
It's comparable. Let's say, for example, if you use Excel, right? If you use Excel, you want to use a standard deviation function, statistical functions, standard deviation formula is the same for SPSS or for Excel. So is very much comparable. The only thing is SPSS or Minitab or JMP, those statistical software, they are catered towards statistics, right? And so the graph that you get might be a bit better, so on and so forth, and is being customized so that it look a certain way that's much more pleasant. But if you use Excel, then the appearance might not be there, but you can do pre-programming such that your data, the data analysis, the result of your data analysis come up very nicely for each session that you crunch your data. So in terms of the validity of the data you get, comparing Excel and SPSS or JMP, so on and so forth, it's the same. It's the same. It's just that you have to know how to use it. The reason why I'm sharing on the capability of Excel, because everybody has Excel in the office, I think. So everybody can do it. Can do some sort of data analytics using Excel.
Okay, thank you. Do we need to have some sort of knowledge or skill to interpret the data?
Yes, of course. that's the thing. But it's not that difficult, in my opinion. The interpretations of the you need to understand certain statistics. But it's basic statistic. It's basic statistics. Because let's say, for example, if you want to run involve ANOVA analysis, for example, on your data, then basically you want to understand what does p value is, f value is, so on and so forth. But it's very easy for you to pick up. It's very easy for you to pick up.
Okay. I have a question from the floor. It say that can the data analytic result is related for marketing and other field that involved in a project?
Can the data analytics
result is related for marketing?
Yes, of course. I think marketing is one of the industry that doing a lot of data analytics. My wife just told me before. He was chatting with his daughter, with her daughter, anak perempuan, to buy certain things from website, right? So they're chatting, and all of a sudden, when she browsed her handphone, using her handphone, advertisement of that particular product actually appeared on the screen. So that indicates there's some data analytics being done by marketing people, actually identify your preferences in buying stuff. So they zoom in based on data analytics and advertise many alternatives to you. So of course, I mean, if you are in that field, marketing is very much applicable to you. What should person? There's another question is what should a person coming from non-technical background learn to start looking on data analytics? I think the first thing that you need to do is understand a bit of statistics. Statistics is very important, be it engineering, be it marketing, be it whatever. So data analytics has something to do with the statistic, but it's not that difficult to do it, to understand, to pick up statistic. My advice to my, especially in my class, so engineers must be very well versed in statistics, because in statistics then you can make decisions in terms of what the data tells you, so what should a controller take a background to start looking at data analytics? I think the first thing that you need to do is understand a bit of statistic. I think that's very important. And other than that, is quite simple. It's data collection, crunching number, and then understanding what the statistic tells you.